Now in the previous lecture, we have implemented 3 methods over here. The first one is responsible for creating stack, the second one is empty method, and the third one is full method. Now here we are going to continue other methods over here. Now the first method that we are going to continue to create in this lecture is push method. So I'm going to put over here push. So we said that push method is responsible for pushing elements to the stack in this case. So I'm going to declare our method like this. So this method will not return anything, so that's why I put over here void. So as a parameter, it's going to take value. So we are going to insert this value to our stack over here. Now the first thing that we are going to do, we are going to check that if our stack is full, in this case we cannot insert any element to our stack. We are going to print out saying that the stack is full. Otherwise we are going to insert elements at the top of previous element in this case. So in this case it's going to be like this. So first if condition will be like this. If stack is full, in this case we are printing out to the console saying that the stack is full. Otherwise, in the else condition, we are going to implement our logic over here. So how we are going to insert this value to our stack over here, we are going to use one more time top of stack. So in this case, when we are creating a stack, we said that top of stack should be -1. So if I put top of stack +1, it's going to be 0. So the first element will be at the index of 0 in this case. So ARR with the index of top of stack +1 will be set to this value over here. So in each step when we are inserting an element to this stack over here, it's going to insert it at the next cell, because in this case we are going to increase top of stack by 1. So in this case our top of stack is located at the index of 0, that's why we are increasing it by 1. Then after doing so, we are going to print out to the console saying that the value is inserted to this stack over here. So I'm going to just print out here saying that the value is successfully inserted. So after doing so, we have completed our method. Now let's see how this is working in practice. So here, as you remember, in our previous lecture, we have created a stack like this. And then here, I'm going to just delete this part from here, and I'm going to insert an element to this stack over here. So here, I'm going to call new stack dot push. So I'm going to push, for example, 1 over here. Then I'm going to push another element over here. Then if I run our code, you'll see that first it says that the stack is created with the size of 4. Then it says that the value is inserted to stack. The value is successfully inserted. Now if I insert, for example, 5 element in this stack over here, it's going to print out message saying that the stack is full. So I'm just copying and pasting this same codes over here and running our code. You see that after 4 element, it's going to say that the stack is full. Now as you see, 4 element is inserted. Then at the end, it says that the stack is full. So one of these messages come from the push method. Another one is coming from the isFull method. Now, if you don't want to see the second isFull message over here, you can just comment this part inside isFull method over here. So when you run our code one more time, you will see that the stack is full shows only one time. You see that the stack is full shows only one time. So our method works the way that we want. Now let's see what's the time and space complexity for this push method over here. So as always, we are going to start from the first line of code. So in the first line, we are checking that if this stack is full or not. So if it is full, we are printing out message to the console. So this part will take a one-time complexity. Otherwise, we are using top of stack as an index over here and updating the cell of array in this case. So we know that updating the cell of array takes a one-time complexity. So this line of code over here will take a one-time complexity. Now then we are increasing top of stack by 1. So this will also take a one-time complexity. Then at the end we are printing out message saying that the value is successfully inserted. So this part also will take a one-time complexity. Now if you combine all these complexities over here, it will take a one-time complexity. Now the space complexity is 1 because in this case we are just updating the value of array in this case. So this means that it will take one space complexity in the memory. Now with this we have finished our push method. Now let's continue to the next method, which is pop method. So here when we are declaring our pop method, so pop method will return the type of integer, because in this case when we are calling pop method, it has to delete the last element from the memory and it has to return that element to the console. So in our case, we have declared the integer type of stack, so that's why it's going to return integer. So our pop method will not take any parameter because it's always returning the last element from the stack. So here the first condition will be like this. We are going to check that if stack is empty, we cannot pop any element from the stack. So here we are going to say that stack is empty. Otherwise, we are going to popping element from the stack over here. So in this case, it's going to be like this. So if is empty, in this case, we cannot do anything. So I'm going to print out to the console saying that the stack is empty. Otherwise, we are going to take the top of stack and save it into the variable. So here I'm going to create a variable like this, top stack, and it's going to set the ARR, and the value that comes from the top will be set to this top stack. So top of stack, we are going to use the top of stack index over here. Then we are going to decrease top of stack by 1, and we are going to return top stack over here. So here also we need to put like this. Then with this we have finished our pop method. So what we are doing over here is we are returning top element from the stack, and we are deleting that element from the stack over here. Now let's see how this is working in practice. So as you remember, here inside main class we have created new stack over here, and then we have pushed 1, 2, 3, 4. I'm going to put 4 elements over here. Now we know that the last element that we push should be at the top of the stack. So when we call the pop method, it has to return the top element and remove that element from the stack over here. Now in this case, I'm going to create integer result and set the value that comes from the pop method to this value to print out to the console. So then I'm going to print out that one to the console. Now if I run our code, now after running our code, we see that we have an error over here. So here we need to return something over here because our method returns type of integer. So I'm going to put -1 over here. So this means that if the method returns -1, it means that our stack is empty. Now in this case, if I go back and rerun our code, you'll see that first it creates a stack saying that the stack is created, then it inserted 4 elements to the stack. So the 4 elements inserted. Then when we run the pop method, it's printing out 4 over here, and 4 is deleted from the stack over here. Now how can we check that 4 is deleted or not? Now if we run one more time stack over here and printing out value, in this time it's going to print out 3 over here. So I'm going to create result 1 over here and printing out that one to the console. You will see that in this case, when you run the second time, pop method is going to return 3. So if I run our code one more time, you see that first it returns 4, then it returns 3. So this means that 4 is deleted from the stack over here. So our pop method works the way that we want. Now let's see what's the time and space complexity for this method over here. Now in this case, the time complexity is O1 because in this case we are just checking that if this stack is empty or not. So if it is empty, we are just printing out message to the console. So this part will take O1 time complexity. Then in the else condition, we are creating top stack variable and assigning top of the stack to this variable, and we are decreasing the top of the stack index by 1 and returning top stack. So these 3 lines of code also will take O1 time complexity. Now if we combine these complexities over here, we will get O1 time complexity. Now the space complexity is also O1 because in this case we are just deleting one element from the stack. So this will take O1 time complexity. Now let's continue to the next method. So the next method, as we discussed, is pick method. Now pick method is different than the pop method. In this case, we are just returning the top element, but here we are not deleting the top element. But in case of pop method, we are deleting top element from the stack, but in case of pick method, we are not deleting the top element from stack. We are just returning it. So here I'm going to just put comment like this, pick method. So I'm going to declare our method like this. So in this case, it's going to be public int pick. So it's not going to take any parameter. So the first thing that we are going to do, we are going to check if stack is empty. So if stack is empty, we are going to print out saying that the stack is empty, and we are going to return -1 over here. So I'm going to write if condition like this. If empty, then in this case, we are printing out to the console saying that the stack is empty, and we are returning -1. Otherwise, we are going to return the top element from the stack. So to return the top element from the stack, we are going to use the top of stack index, and we are going to return it from the array. So it's going to be like this: return ARR top of stack. So with this, we have completed our pick method. Now let's see how this is working in practice. So here, instead of pop method, I'm going to call pick method twice to see what is the results. So in this case, as you remember, when we call pop method twice, if the top element removed, so the next top element is come to the console. But in this case, if we run pick method twice, it's going to print out the same element to the console. So if I run our code, you see that when we run the pick method twice, in both times it's printing out to the console 4. So it's not removing the element from the top of the stack. Now let's see what's the time and space complexity for this method. So it's obvious that this all operations over here takes O1 time complexity. So this means that the pick method will take O1 time complexity, because here we are just checking that if this stack is empty, we are returning message, we are returning -1 and printing out message to the console. Otherwise, we are accessing the element with the index of top of stack in this array and returning that element. And it's obvious that accessing an element of array takes O1 time complexity. So this means that this method will take O1 time complexity. Now the space complexity is also O1, because here an extra memory is not required to perform this pick method over here. Now finally, the last method is delete method. So in this case, delete method is responsible for deleting stack. So here, all I have to do, I'm going to set this array that we have declared over here to null. Then we are printing out to the console saying that the stack successfully deleted. So our method will be like this: public void delete stack. Then inside this method, all I have to do, I have to set ARR to null, then printing out to the console saying that the stack is successfully deleted. Now with this, we have successfully implemented a method which is responsible for deleting of stack. Now let's see how this is working in practice. So here again, inside main class, after creation of our stack and inserting some elements to our stack, I'm going to call delete method. And if I run it, you will see that our stack successfully deleted from the memory. Now you see that it says that the stack is successfully deleted. Now the time complexity for this method will take O1 time complexity, because here all we are doing is we are setting ARR to null and we are printing out message to the console, and the space complexity is also O1. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented main methods in stack using array. Now hopefully everything is clear about these operations over here. So see you in the next lecture.